All right, welcome to section 2.7, which is all about graphing absolute value functions. Um, and the absolute value function that we want to talk about today is this equation right here. It's y is equal to a, and then you have the absolute value of x minus h, and then you have plus k. So the variables that we're going to worry about here are really the variables of a, and then we're going to talk about h, and we're going to talk about k. Okay? So what I've done here is I've taken and I've put a list of all the translations and transformations that we can actually have when we're talking about absolute value functions. And before we talk about these translations and transformations, I think it's really important to realize that this graph right here, or excuse me, this equation right here, y is equal to the absolute value of x, this one right here is known as your parent function. All right? Every single thing that we're going to do, all right, and the translations and the transformations that we're going to make, we're going to relate it to this parent function right here, okay? So what I'd like to do first, I think, is I'd like to take a look at this on the calculator and see what it looks like. That way, then we know exactly how these things over here are going to affect the parent function, okay? Um, so when graphing absolute value functions, what you're going to have to do is you're going to have to go to this math button right here. You're going to have to click over to number, and you're going to have to go ahead and find the absolute value. You're going to go ahead and you're going to enter when you find it. Now yours might actually show the absolute value bars, but my calculator with my operating system says ABS, and then inside parentheses I'm going to go ahead and put X, and I'm going to close that. Okay. You might have to put the X inside of the absolute value bars and then arrow over to go ahead and get out of the absolute value. And then all I'm going to do is I'm going to hit graph. And this right here is what the absolute value parent function of y is equal to the absolute value of x looks like. All right. Now you'll notice the table here. I have -2. My output value is 2. -1. Output value is 1. And that makes sense, guys, because if you took -2 and you put it into the absolute value, you get a positive that comes out. Okay? So this one right here starts at the origin, 0, 0, and that's this ordered pair right here, 0, 0. And then you'll see what we have as it goes to 1, 1, 2, 2, 3, 3, and so on and so forth. Also, if you put a -1x in, you get a +1 output. -2 gets a +2. All right, so really with this one, we kind of are going up 1 over 1, up 1 over 1. Same thing, up 1 to the left 1, up 1 to the left 1. Okay? So that right there, guys, is your parent function. All right? Now, here's what happens. We may have something like this, okay? Y is equal to negative, and then you have x plus 1 inside the absolute value, all right? What we want to look at is we want to look at this number right here, which we know is a -1, and that falls in the a value. So we have a is equal to -1, okay? Also, we have my h value, all right? Right here it says +1, and this says x minus -1. So really what we're looking at is we're looking at x minus a -1. So my h value really is -1, and then k back here, I really have a +0, so we have 0. Okay? So now we have to answer my 3 questions for this. Part A wants to know whether or not the graph is going to open up or down. We're going to look at my a value. It is negative. All right, so what happens is it follows rule number 3. We know that the graph is going to go ahead and open down. All right, part B, all right, wants to know identify the vertex. Okay, so the vertex is h comma k. So we have h, we have k, so we know that my vertex is going to be -1 comma 0. So this graph shifts to the left 1. And then part C wants to know whether or not the graph is narrower, wider, narrower, or exactly the same. Okay? Wider, absolute value is less than 1. Narrower, absolute value is greater than 1. So if we end up with it equal to 1, right, like this one right here, we're going to go ahead and we're going to have the same as your parent function. Okay? So let's go ahead and let's take a look at this now. I'm going to go to the calculator. I'm going to graph it to see exactly what it looks like. All right, so I had negative absolute value. Okay, so I'm going to go back to y equals. I'm going to go down to y2. I'm going to graph them at the same time. Go get my absolute value, scroll over to number, hit enter, and what I should have done before that is I should have hit a negative sign before that. So I'm going to have to go back to math. Alright, absolute value, and then we had x plus 1, close that. I'm going to hit graph. And what's going to happen is your y1 right here is going to graph first, then your y2 is going to graph second, and you'll see the difference between them. Alright, like I said, shifts to the left, opens down, is the same width. Alright, excuse me, is the same as original parent graph. Okay, if we went here to number 2, alright, in this one, my a value is equal to 7. My h value, alright, is equal to 3. And then my k value is equal to negative 4. So let's go ahead and let's take a look at what's going to happen here. A value is positive. You got a positive 7, so my graph is going to open up. B, my vertex, all right, my vertex is going to be at 3 comma negative 4 because it is hk. And for letter C, this a value, all right, the absolute value of 7 is greater than 1. So we know that this graph is going to narrow, all right, or we could go ahead and say it's going to stretch. All right, so that's really what we're doing by looking at this. We're trying to figure out exactly what's going to happen to the graph and to the parent function, okay? So let's go down here to figure out how we're going to go ahead and we're going to graph these things. All right. So if you wanted to go ahead and graph these, we could start off with by just doing a t-table. That would be one way that we could do it. So I could go ahead and I could draw this in. All right. My a value here is equal to 1 because that's my number right in front. My h value, there's nothing inside here, so it's going to be 0. And my k value is this part right here, so I'm going to have negative 3. So I know that my vertex is going to be 0 comma negative 3. And I'm going to use that point right there as my starting point. Right? Now, with absolute value functions, what happens is you're going to choose a number that's bigger than, and a second number that's bigger than, and then smaller. All right? And it's going to go ahead and it's going to mirror. So whatever we get for this 2 is also going to go down to negative 2. Whatever we get for 1 is going to go to negative 1. If I took 2 and I put it in here, absolute value is 2, minus 3 would give me a negative 1. So I know that this down here is also negative 1. Absolute value of 1 minus 3, I'm going to get negative 2. So I'm going to get negative 2 right there. And now I'm going to go ahead and plot these points. 0, negative 3. All right, 1, negative 2, 2, negative 1, and same on the other side. All right, and then we'd go ahead and we would graph this. All right, and we would go ahead and we'd graph that from its vertex. All right, and you notice what happens is this minus 3 goes ahead and it shifts down 3. My a value is positive, so the graph opens up. All right. So this one right here, if we wanted to go ahead and make my t-table again, x comma y, what we want to do is we want to figure out what my vertex is first. And this is a negative, it's x minus 3, so we know that my vertex is going to be 3, comma, and there's a plus 0 right here, so it's going to be 3, comma, 0. So now, when you make your t-table this time, your vertex is 3, comma, 0, which means now 2 points that are smaller than 3, 2 and 1, and then you got 4 and you got 5. If you took and you put 1 here, you'd end up with negative 2. The absolute value of negative 2 is positive 2. So this right here is also going to be positive 2. Take and substitute 2 in for x. 2 minus 3 gives you negative 1. Absolute value of negative 1, positive 1. Positive 1 goes here. All right. So now we go ahead and graph 1, comma 2, 2, comma 1, 3, comma 0. And then you come here and here. And go ahead and you construct your absolute value. Okay? So this one, you notice that this right here, that went ahead and it made it shift 3 units right. Okay? All right, let's go to the next page. Now I really want to take and show you a shortcut for how to graph these things. Okay? So here's what we're going to do. You're going to go ahead, find your vertex. All right, and this one right here, this is your H, this is your K. Okay? So you know what's going to happen is your vertex is going to be -1, comma, -1. All right, because this would say x minus a -1. Your a value is equal to 2, and we'll talk about that in a second. So, vertex, -1, -1. I'm going to go ahead and put it right here. Now, this is almost like saying 2 over 1. So what you can do is you can start at your vertex and you can go up 2 over 1, up 2 over 1, up 2 over 1. Same thing. You can go up 2 and you can go to the left 1, up 2, left 1, up 2, left 1. And you have just graphed, all right, absolute value. All right. This one right here is going to be narrower than your parent function because this number right here is greater than 1. Okay? The absolute value is greater than 1. So let's go ahead and let's try this one. For number 2, you got your vertex. What is your vertex for this one? Well, you got your H and you got your K. We got 3 and we got 2. 3, 2. This number 1/2 right here, that's kind of like, that's your a value. You got 1/2. You're going to go up 1 over 2, up 1 over 2, up 1 over 2. And this one, guys, since since the absolute value of a is less than 1, this one right here is a wider graph. What's this one going to do? This one would go ahead and face down because it is a negative. Okay? All right, and then the last part of this one is just going ahead and writing the equation. Step 1 is to always go ahead and determine what the vertex is. So your vertex in this one, all right, is at -1, comma 2. Your a value for this one, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So it's a +1. So if you wanted to write the equation in this one, y equals, your a comes next, but it is a 1. So you're just going to put the absolute value of x opposite plus 1, and then you got plus 2. Here's your equation for that one. Okay? Vertex is at 2, comma 3. And what happens is, for this one, you go down 2 over 1, down 2 over 1, down 2 over 1. So your a value is equal to -2. So if you wanted to take and write the equation for this one, you're going to say y equals, now the -2 goes up front, that's your a value, and then you have x minus 2, and then you have plus 3. All right. If you ever get lost, guys, you can always go to your calculator, like I said, and graph these things. And then if you want to, you have your, if you go to second table, this right here will go ahead and make your t-tables for you. Okay? That concludes section 2.7, which is about graphing absolute value equations. Next to come, 2.8, we're going to talk about graphing inequalities, linear inequalities, and absolute value inequalities.